Alright, here we're going to go over some special cases. So, our first example is y greater than 3. So when it's just y with no x, that means it's going to be a horizontal line, meaning that it's going to go through y. So if it's just y by itself, it means that it's going to be a line that's going through the y-axis, so a horizontal line. So since this is y greater than 3, so it's going to go through the y-axis at 3. So right here, 1, 2, 3. Now based on this inequality sign, so for our special cases, you don't have to identify your slope and y-intercept because it's a special case. But it would help if you identify that based on this inequality sign, it's going to be a dotted or a dashed line. And since it's facing y, opens to y, you're going to shade above. So again, since it's just y by itself, that means it's going to be a horizontal line going through the y-axis. So if you see the y by itself, it's going through the y-axis. So this would be my line. And then it's going to be shaded above the line, just like this. So that's all you have to do. Now, the reason I call it a special case is because unlike the previous example, your graph line was slanted and going from left to right up and then from left to right down. Now this one is just a horizontal line with no x. So if it's y by itself, a horizontal line where y is greater than 3, that means any area, any numbers greater than 3 will be shaded. Alright, we have a second example with a special case. In this special case, this second example is y less than or equal to -4. So there's no x and it's just y. So again, when y is by itself, it's going to be a horizontal line going through the y-axis. So here, based on our inequality sign, it has that line underneath, so it's going to be solid. Since it's facing away from y, it opens away from y. It's going to shade below. So what we're going to do is going to graph our line through -4. 1, 2, 3, 4. So -4 on the y-axis. It's a solid line, so it's going to be like this. Now, once you finish graphing a line, then shade below. Just like that. So again, when y is by itself, it's a horizontal line that goes through the y-axis. Next, we're going to talk about when x is by itself. So pay very close attention to that because it's going to be a little bit different compared to with our shading below, shading above with y. But the same process will be the same for solid line and dash and dotted line. In this example, it's x greater than -5. So based on our inequality sign, it's going to be a dotted or dashed line. Now what's different is that if it's x by itself, that means it's going to go through the x-axis, so it will be a vertical line. Now typically with the special case where y is by itself and the previous example, we talk about shading above and below. So let's compare to the previous example. Since it's facing the X, so it opens to the X, that means it's going to be shading above. Now the problem is it's going to be a vertical line. So you won't be able to tell where's the above or on top of the line. So when it's shade above, meaning X is greater than -5, it means that you're going to shade left. Excuse me, not left, right. So shade the right side. And here's what I mean. So first, we determined that it's going to be a dotted or dashed line at -5. So at -5, 1, 2, -1, -2, -3, -4, -5. Again, since X is by itself, it's going to be a vertical line. It's going to go through the X-axis. So when X is by itself, it means that it will be a line going through the X-axis. So therefore, a vertical line. Dotted or dashed line, so just like this. So when it's facing X, just like the other example, you would say shade above. But when it's X, in this special case by itself, that means that you're going to shade the right side. And if you were to think of this logically, it says X greater than -5. So what numbers are greater than 5? -4, -3, -2, -1, 0, or greater than -5. Then you can pick any numbers here. 2 greater than -5, 3 greater than -5, 10 greater than -5, 13 greater than -5. So all these numbers will be greater than -5. So that means you're going to shade this side. So just like that. To compare, if it's facing the variable, it's going to be shaded above. So in terms of the special case where X is by itself, if you have shade above, that means you're going to shade the right side. But if you were just to think about in terms of the number line or number logic, numbers that are greater than -5, -4, -3, -2, -1, 0, 1, 2, 3, and so on, those numbers lies on the right side of -5. So therefore, this side will be shaded. Now let's talk about when it's going to be facing the other side. In this fourth example, it's X less than -1. Now let's change it to less than or equal. Now the one we did before was a dotted or dashed line. So this will be a solid line. So X less than or equal to -1. So again, since it has that line underneath the symbol, it's going to be a solid line. Now, since it's facing away from the variable, typically, just like the previous examples, it would be shade below. Now, when we're dealing with X, it means shade left. So you can shade the left side. And you see why. So, again, since X is by itself, it's going to be a vertical line going through the X-axis. So again, it's going to be a line that's going through the X-axis. That's why it's going to be a vertical line. At -1, so right here, again, it's going to be a solid line, just like this. Alright. Now again, if you determine that it's shade below, it means you shade the left side. So let's think about this as a number logic. X less than or equal to -1. So less than, if we focus on the less than, numbers that are less than -1 is typically -2, -3, -4, -5, and so on. So those numbers lie on the left side of the line, or left side of -1. So therefore, we're going to be shading the left side, just like this. So again, if you think about in terms of number logic, x less than or equal to -1, meaning what numbers are less than -1? So -2, -3, -4, -5, and so on, meaning numbers that are on the left of -1. So therefore, you're going to shade the left side of -1. But you're thinking about in terms of the previous example, like, hey, it's facing away from the variable that's shaded below. But when we're working with x, which is a special case, it means shade to left. So make a little note, when graphing where x is by itself, if it's shade above, you're going to shade to right. If it's shade below, you're going to shade left. So I repeat, if it's shade above, shade the right side. If it's shade below, shade the left side, but only for x. Another method to connect with is number logic. X less than -1, those numbers lie on the left side of -1. -3, -6, -7, -10, and so on. Now, if it was x greater than, so that means numbers on the right. 2, 11, 30, and so on. So the right side. If it's on the right side, you will shade the right side. If it's on the left side, you shade the left side. So make sure you have that little information in your note, or a little guide, a little hint on how to memorize when shading on the left and shading on the right. For only example where x is by itself.